Okay. More volume, more revolutions. What? Sure. Sure. Example 5. Thank you. Area bounded by we're going to take the area bounded by y equals x squared and x equals y squared revolved around the y-axis. Now, yes, we've done x equals y squared and y equals x squared a number of times. We did it for area between curves. We did it for revolving around the x-axis. Now we're going to take it and revolve it around the y-axis. We're going to have a good time. And I don't care what you say. What? It probably will be the same, I'm guessing. I haven't really thought the whole thing through, but it doesn't really matter. It's just the process is what's really important to us right now. Okay? So, what should I do first? Good. Draw a graph. Y-axis. Everybody agree that that's the region that we've talked about? Okay. Now let me okay, so I'm going to take this and I'm going to revolve it around the y-axis. So I'm going to get this type of shape. Everybody agree that that's what I got? I'm going to draw a spot in the middle here where I'm going to cut it. Try something just a little bit different. That kind of looks pretty cool, huh? So I just cut it. What's different about how I cut it? Yeah, I sliced it horizontally. So that means that I'm going to integrate instead of left to right. I'm going to integrate from bottom to top. So I got to take out an infinite number of those slices. So now when I draw my shape, I can draw my washer over here. That's what I cut out, right? All right, what's that? What is it? Yeah, it's y. It's x equals 0, right? Hold on. Now it's x equals. So what do the others have to be? Very good. Let's do this guy right here. What forms the outside of the washer? Right. The outside of the washer is y equals x squared, or x equals the square root of y. We had to solve for the variable in terms of y. then the other one would be y squared. Is everybody clear about that information? Okay, so I've got this washer. I just cut it out. So what I want to do is I want to find the volume of that washer. What's the width? What's that width? The thickness of each washer. dx. So now in order to find the area of the top, I got to use that washer method. So again, we're going to have pi times r squared minus r squared dx. That will be the volume of each washer, and then I'll integrate that over the entire region that I'm using. So, isn't it cool how many things you're doing? So let's look at the big radius. What's the distance from 0 to square root of y? Square root of y. So I got pi times the square root of y squared minus, what's the inner part? Y squared. dy. Sorry, dy. We all know that. Shut up. All right. Sorry. dy. Okay, so let's integrate. We have pi times, the integral is what's going to add up an infinite number for us. And so we're going to start at, where's the bottom of this guy? 0. And how high does it go up? Do you remember the bounds that we had? It does go up to 1. Okay. Yep. It's both. They intersect at 1, 1. No, they don't. No, they don't. Okay, we integrate. We're almost done. We got pi times, what's the antiderivative of y? Y squared over 2 minus y to the 5th over 5. Evaluated, 0 and 1. So we've got pi times 1 over 2 minus 1 over 5, or pi times. So we've got 5/10 minus 2/10. Power over 10. Escape. Holy crap. She was so angry. All right. No. All right, everybody done? Hurry up! I want to do example 6. It's so much more exciting. I have to. What if I don't? What are you guys going to do? You're not going to do your side homework? Oh, no. What will I do? We're all going to fail the test. Oh, that'll ruin my future. Berkey, do you got it? Oh, that's right. We kind of broke a rule. We had to befriend Chrissy in order to actually get a copy of the picture. So don't be surprised if you're unfriended very soon. So I'm sorry. Okay, this was great. This is kind of ties a lot of things together, and I haven't even showed you this cylindrical method, which is sometimes referred to as the shell method. It's really cool, and we'll learn that next week. But today we're going to do one more vertical one. Question. So another vertical one. Okay. So area bounded by x plus 2y equals 2, y equals 0, x equals 0, revolved around x plus 3, or x equals 3. So we want to draw our region, but if you have x equals 0 and y equals 0, that refers to one of the 4 quadrants, correct? And this intersects with the first quadrant. Okay. So let's draw this out. Okay, what does the line x plus 2y equals 2 look like? What are the y-intercepts of that graph? So when it's in this form, let's just remember, let's go back to basic math. If x is 0, what's y? 1. If y is 0, what is x? 2. So you know your x-intercept is 2, and you know your y-intercept is 1. So that is our line. If you need to put it in slope-intercept form, then fine, but hopefully you can see that. Okay? So we're going to take this region right here, and we're going to spin that around, and we're going to spin it around the line x equals 3. Okay? What? Yeah. So we're going to get the same shape over here. Not an avocado. Did I kind of get it? Did I kind of capture it? See what's happening? A war shirt. Very good. So, A for the day, Greta Johnson. How do I want to slice this? Do I want to slice it vertically or horizontally? Horizontally. Excellent. So, I'm going to slice it. You see why I'm continuing to draw stuff through it. So, if I slice it horizontally, I have, thank you. I have, this is solid area right here, correct? And this is solid area right here. But I have empty stuff in the middle. So again, as Greta said, you get a washer or a washer. Yeah, funnel shaped. But when we slice it, regardless of what the overall shape is, we do get a washer. Okay. Very good. This is x is equal to 3. You tell me this, though. What's this right here? Good. X equals 0. Excellent. How about this one? I got to solve for which variable? X, so I get X is 2 minus 2y. Because they all have to be solved for X. Because we're going to differentiate with respect to y. So we need to figure out the volume of this washer. So I have pi times my large radius. The large radius is going to be the distance from, you always move right to left or top to bottom when you're trying to find these lengths or distances. So if I want to do the large radius, I have to go from 3 minus 0, which is 3. So that's my large radius. I have to square that. Minus my small radius. Now, this is where the mistake happens. A lot of people will go 2y or 2 minus 2y, and then they'll subtract 3. Again, you have to start from the right and move to the left, okay? Always, always, always. So 3 minus, parentheses, 2 minus 2y squared dy. That's the volume of one of the washers, correct? So I always go right, subtract, left. Just as though, I mean, what the math, so this is all about the mathematics. You know, if you want to know the distance from, 6 to negative 3, you always take 6 minus negative 3, right? You wouldn't want to do negative 3 minus 6. Because that would give you negative 9, and negative 9 is not a distance. Can a radius be negative? No, so you always take the right minus the left. Okay? Our bounds? I don't really know. Let's set our bounds up. Like, we're going to slice it horizontally, right? So let's think about this. As we slice it, where's the lowest x value or y value for which we slice? 0. Where's the highest y value for which we slice? 1. I know, I know, okay? And this is very common. People might say, well, I want to go from, say, 0 to 6. Well, remember, you're going to slice it horizontally. So you just have to think about that motion. And if you don't like it, then go like this. Get yourself to draw them every time. Where do you start drawing? Remember, if we're going y, then our bounds have to be y. Your bounds have to correspond with the variable that you're using. Okay? So we're making all those cuts. We go from 0 to 1. So let's set it up. We've got bounds from 0 to 1. Pi times 3 squared is 9 minus, let's go, 3 minus 2 is 1. And then 3 minus 2y is minus the negative 2y. We'll have a plus 2y, correct? So 3 minus 2 is 1, and then a minus a negative 2y be a positive 2y. And then we're going to have to do this part as well after I square it out. dy. Now we just have the algebra. We have pi times the integral from 0 to 1, 9 minus, parentheses, FOIL this out. Very good, Devin. You're welcome. Okay, so that's going to be a negative 4y squared minus 4y, and 9 minus 1 is 8. Do you want to factor out a 4? Let's factor out a 4. Sure. What? You can do it. There's no problem factoring something out. Well, you need to take the antiderivative. Oh, Ben. All right. Stupid. You wanted to evaluate the bounds without even taking the antiderivative. Who does something like that? All right. Okay. All right. So we got negative 4 pi times. What's the antiderivative of y squared? There'll definitely be a phone call after this video, right? All right. It doesn't matter. It doesn't matter. Oh. Except when you take the test. All right, so negative 4 pi. I plug in 1. I get 1/3 plus 1/2 minus 2. Or negative 4 pi times 1/3 plus 1/2 is 5/6 minus 12/6. 5/6 minus 12/6 is 1/2 point off. Got to reduce. It doesn't matter. There's... No, the only reason I'm intimidated by you guys is that there's 36 of you and there's only one of me. I think that would be... Yeah. Why don't you ever just like totally jump them? Take them on. Oh gosh. Hog pile against now. You guys, you have a full work day tomorrow to work on this stuff. And you guys, if you could get this stuff, you're just gonna be in great shape. I mean, if you know how we're doing this stuff, you're money. Nobody talk to Kyle Zog the rest of today or all of tomorrow. He does not exist. Ready?